Okay, so last time we looked at quantities that described the location of an object or a trip, right, of an object. We called those positions and displacements. They're just how the object or how to express where a thing is relative to another thing. If it's relative to the origin, it's a position. If it's relative to another point, it's a displacement. Now, what I'd like to do is I'd like to talk about those other things. So other things can be vectors as well, and we'll just use the rule of thumb that quantities that modify the position are vectors. Okay. For example, the velocity changes position. So that's a vector. On top of that, the acceleration, remember, changes velocity. And the velocity then changes the position. So the acceleration is a vector. All right. What happens with, let's say, the force? The force causes acceleration. So it's a vector. So all of those things are vectors. Right? And there are other vectors that we'll talk about later on. I tried to think of vectors that really had nothing to do with the position, and I couldn't. Although I could think of a couple of that were a little bit weird. Those are technically called pseudo-vectors that you'll meet in later on. You'll meet a pseudo-vector, and later on you'll meet a and in the next class in physics 2, you'll meet a pseudo-vector. But you don't have to worry about what they are right now. In fact, we'll completely ignore that they're pseudo-vectors when we talk about them. So you don't even have to worry about that. You'll notice that these things have some things in common, like the velocity is equal to delta x over delta t. And the acceleration is equal to the change in the velocity over the change in time. You'll remember those. So both of these we have to divide a vector by this delta t, which is not a vector, it's just the difference in time. Time is not a vector. There's only one time, at least for now. And so we have to figure out how to actually use this. So what we'll do is we'll say multiplication by a scalar distributes to all of the what should we call those things? Components of the vector. Right? We just talked about the x component, the y component, and the east component, and the north component, and all that sort of stuff. So that if you have a displacement d, it's going to be the velocity times the time. Velocity has an x component and a y component, right? We multiply that by the time. We just distribute that in, right? So each component gets multiplied by t, vxt, vyt. That looks pretty good. But when we look up here, these definitions all have us dividing by time, not multiplying. So what's its trick for that? Well, if we have a velocity, that's delta x over delta t. So we've got this vector. Let's just call it xy over whatever delta t is. Let's just call it t. Well, I called it delta t. And I called this delta x and this delta y. So this is just a displacement It's going from one place to another. And this is a duration, how long it took. So we now have this number, right, which is just 1 over time. So this is just like, so division is just like multiplication, right? So you can't divide by a vector, but you can divide by a scalar. So you have delta x over delta t, right? T goes, multiply 1 over delta t times 1 over delta x, it's that. And we have delta y over delta t. Okay, that seems reasonable. And so that's more or less what we have for how we accomplish that. If we're going to multiply by a scalar, we just multiply each component by that scalar. If we're going to divide by a scalar, we just divide each component by that scalar. Scalar is just a number, just a number. And that lets us talk about things like velocity and acceleration as vectors, right? Because we define them as, something like this. V is equal to the change in position over the change in time, but now that position is a vector. So we need to be able to express that change in position, that displacement, divided by some number somehow. And this is just the way we do it. Take each component and divide it by the time. I'll give you an example of that, and then we'll come back and we'll talk about finding magnitudes and directions, right, of these vectors.